Welcome to a video that will show how to use determinants to find the area of a triangle and parallelogram on the coordinate plane. The area of a triangle on the coordinate plane is equal to plus or minus 1/2 times this 3×3 determinant, where each row is formed by using the coordinates of one of the vertices, with each element in the third column equaling 1. Now the reason there's a plus or minus here is that based upon the order in which you place the coordinates in the determinant, this value may be positive or negative. We know that area is always positive, so if the value of this determinant is negative, we would multiply it by negative 1/2, and if it was positive, we'd multiply it by positive 1/2. So we don't have to be too concerned about how we place the coordinates into the determinant. Let's go ahead and give it a try. The area of this triangle will be equal to plus or minus 1/2 times this 3×3 determinant, and let's go ahead and start with the point 5, 2. So the first row would be 5, 2, 1. Let's go to the point 3, 4. So we'll have 3, 4, 1. And then the last point would be 1, 1. So we'll have 1, 1 for the point, and the third column is always equal to 1. Let's go ahead and find the value of this determinant. Let's use the diagonal method. So we're going to go ahead and first copy down these first 3 columns, and then we're going to copy down the first 2 columns again on the end here. So we'll have 5, 3, 1 and 2, 4, 1. And now we'll find the product of the diagonals starting from the left moving to the right. So we'll have 1, 2, 3 products here. Let's go ahead and find these. So we'll have 5 times 4 times 1, that's 20, plus 2 times 1 times 1, that's 2, 1 times 3 times 1, that's 3, and then we'll subtract the product of the diagonals that start from the right and move to the left. So we'll have a product here, here, and here. So we'll have 1 times 4 times 1, that's 4. 5 times 1 times 1, that's 5. And then lastly we have 3 times 2 times 1, that's 6. So it looks like we're going to have 25 minus 15, which is equal to positive 10. So we're going to go ahead and take the value of this determinant and use it to find the area of this triangle. So the area, because the value of the determinant is positive, it's going to be 1/2 times 10. So the area is equal to 5 square units. Let's go and take a look at one more problem. Now we have a parallelogram, and we're going to use the formula for the triangle to determine the area of this parallelogram. So what we can do here is first label all of the coordinates. This is the point 0, 1, 6, 3, 5, 4, and negative 1, 2. So what we can do is break this parallelogram up into 2 triangles. So if we were to draw the diagonal from this point to this point, and the diagonal forms 2 congruent triangles in our parallelogram, so we can find the area of this triangle here and then just double it to find the total area. So let's call this area 1, and this will be area 2. So area 1 is going to equal plus or minus 1/2 times the value of a 3×3 determinant. So let's go ahead and set this up. Let's start with the point 0, 1. So this first row will be 0, 1, 1. Let's go to this point here. So we'll have 5, 4, 1. And the last point will be 6, 3. So 6, 3, 1. Let's go ahead and find the value of this determinant. Let's use the cofactor expansion this time. So if we want to use this first row, we're going to have 0 times the determinant formed by deleting row 1 and column 1, so we'll have 4, 1, 3, 1. Now when we go to this next element, it's going to be minus 1 times the determinant of, if we eliminate row 1 and column 2, we'll have 5, 1, 6, 1. And then for the third element, we'll have plus 1 times, again eliminating row 1 and column 3, 5, 4, 6, 3. Let's see what this gives us. Well, of course, this would be 0 minus 1 times, this will be 5 minus 6, so negative 1, plus 1 times, this will be 15 minus 24, that'll be negative 9. So we'll have 0 plus 1 minus 9 equals negative 8. So since the area of this triangle is obviously positive, the area is going to equal negative 1/2 times negative 8. So the area of one of the triangles is equal to 4. And since these triangles are congruent, or area 1 is equal to area 2, we can just multiply this 4 by 2 to find the area of the parallelogram. So the total area will equal 2 times 4, or 8 square units. Now if it wasn't a parallelogram, but just a quadrilateral, we would have to find the area of the two triangles separately because they wouldn't be the same, and then add them together. So this is kind of a nice application of determinants. And we also got a chance to review how to evaluate a 3 by 3 determinant by both the diagonal and cofactor expansion method. I hope you found this helpful. Thank you.